Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So today I am going to discuss about the part 2 of alternating current, and we will basically focus on the mean or average value. What is mean and average value, right? So let us discuss about this. So it is defined as the value of the AC or alternating current which would send the same amount of charge through the circuit in a half cycle that is sent by steady current in the same time, and it is denoted by I mean or I average. Now let us consider there is a there is a alternating current source AC source, and you know that the AC current source is in the form of either sine wave or cos wave. So this is your sine wave or a cos wave, got it? So here current is in the form of I is equal to I naught sine omega t, right? But we are not getting the exact current value. Why we are not getting exact value? Because the current is basically changing from one time period to another time period, right? So it is very much difficult to analyze. So we need a value or discrete value so that we can say or we can use it. So we can find the average of the current, which will be equal to the steady current. If I will tell, if if the maximum current is 5 ampere and minimum current is 0 ampere, so we cannot tell that the amount of current which at a particular time. See, at a particular time it may be 3 ampere, at another particular time it may be 4 ampere. Our main focus is to find the amount of the current which we can say that it is sending amount of charge sending the same amount of current. For example, this is your 5 ampere and this is your 0 ampere. Now we have a this is your 3.5 ampere. So the amount of charge sending by 3 ampere current in a t by in a time period of a t by 2 is equal to, see here, the amount of charge sent by this AC current and the amount of charge sent by this steady current is same. Then this current is known as I average current. Then this current is known as I average current. Okay. So basically average means what we need a discrete value so that we can use that value. We cannot use every time variable value. So let us find the I average. So how you will do the I average current? Uh, Definition you have understood, right? Definition you have understood. Now we will try to derive it. So let us consider this is a circuit, this is our axis, and this is your cycle like this, half cycle like this, half cycle like this, half cycle like this, right? This is your positive half, this is your negative half. If you take average of the full cycle like this, if you will take average of full cycle, then what will happen? The amount of quantity is, suppose that this is your 20 ampere, and if we take the average of this also minus 20 ampere, because the magnitude of the both the upper cycle and lower cycle will be same, so this will become 0, so it won't work. So whenever we want to find an average current, so we have to take a half cycle only to find an to find average current average current we need half cycle only, cycle. So for this what to do? So we have to take make a average. So we know that mean or average amount I average. If you want to find I average, so what to do? See here, I average is equal to total current, amount of current divided by total time. Now the thing is that our current is variable, so what should we do? We should integrate. So if we will integrate it, so let us integrate it from 0 to t by 2 cycle. Why? Because if we will take full cycle, so it will create a 0, so no, we cannot get a average value, right? So we should get the average value only magnitude. So we will use here I average is equal to instant I dt divided by time period. How much time we are taking? Total time. total time 0 to t by 2 and dt. Okay, so finally what we will get in next slide, I average, we can say I average as equal to integration 0 to 2 t by 2 I naught sine omega t dt. Why I naught sine omega t? Because instantaneous current, our current is variable, so our current will be in the form of I naught sine omega t, right? So divided by 0 to t by 2 dt. So if you integrate it, so what we will get? Let us change the color so that you can understand it more properly. Now this will be I naught integration of 0 to t by 2 sine omega t dt divided by t by 2, because integration of dt with limit of 0 to t by 2 will become t by 2. So finally we are getting 2 I naught divided by t, and when we integrate it, so integration of sine omega t will be how much? So it will be minus cos omega t divided by omega, and its limit will be from 0 to t by 2. Now if we will put the limit, so what should we get here? 2 I naught by t, we are already getting it. So first of all we will have to put here, can we take this omega is the t omega here also? So we will be minus cos omega t by 2 minus cos, minus minus it will become 0, cos 0, right? Now see from here what we can put here, we can write here 2 into I naught divided by t omega, value of omega is equal to, or t omega. So let us find the value of t omega. Omega is equal to 2 pi by t, or from here t omega is equal to 2 pi. So wherever we will find 2 omega, so we can write here 2 pi. So in place of t omega we can write here 2 into pi, and now omega t again, omega t is equal to 2 pi by 2 minus cos 2 pi divided by 2 plus 1. So now tell me, it will be 2 will get cancel out, so finally we are getting 2 I naught by 2 pi into cos minus cos pi is equal to minus 1, so minus minus will get cancel out, so this will be 1 plus 1. So finally I average, so I average is equal to this, so this will be 2 I naught divided by pi. So this is the value. Now if you calculate it furthermore, so what we will get? We will get I average is equal to 0.637 I naught. So it means that if you want to find the I average current, so it will be always 0.637 times of the I naught. If you observe it graphically, so let us consider this is a graph, and we have a cycle like this. We have a cycle like this, and we have a maximum current. Suppose maximum current is your I naught, and which has a value of 20 or 200. We want I average, so I average will be how much? So I average will be how much? So I average is equal to 0.637 times of the I naught. So this will be 0.637 into 200. So this is basically a 63%. So it may be around this one, 60, more than 50%. So this will be approximately equal to 63%, means 120, more than 120 ampere. So this is the I average current. So this you have understood. This is the literal meaning of the I average current. So I average will help you to identify that what amount of exactly the current is flowing, because you cannot analyze it with the variable current. So again I am telling you, please observe the definition. It is defined as the AC current which would send same amount of charge. Let us consider same amount of a charge. Let us consider this is the I average current, or the a current which is sending same amount of the charge through the circuit in a half cycle T by 2, that is sent by steady current in the same time. So if you are taking this as a current, let us consider let us consider this cycle is sending in a half cycle 100 coulomb. So this 120 ampere, that is I average current, will be also give 100 coulomb of a current for a time period of a T by 2. 100 coulomb of a charge, it will also supply us same amount of charge. If this variable current is supplying 100 coulomb of charge in T by 2 time period, then this 120 ampere will also supply 100 coulomb of a charge for the same time period, but this will be the constant current. That's why this its value is like this. Okay, so I hope you have understood this, and if you have enjoyed this session, so in next class I will again discuss about the IRMS values. Thank you for watching my video.